All right. For number 12, you should get 15.426, 16.189, 16.241, 16.242. 15 is 21.217, 22.217, 22.440, 22.459. 18 is 0.273. 21 is no. 24 is yes, and your ratio is 3/2. 27 is no. 30 is F. 40 is A. 33 is A, 36 is G. 50 is X equals 1. How about 54 is X equals 1? Wow. 57 is, we have to do quadratic formula, 1.816 and 0.184. 60 is X equals 3. 63 is 3/2. 66 is -6 and 2. 69 is a fourth. That one's a little weird. 90 you should rewrite as log base 3 of 9 equals 2. 12 is log base A of 2.1 equals 3. 15 is log base 2 of 7.2 equals X. 18 is log base X of E equals pi. 21 is 2 cubed equals 8. 24, B squared equals 4. 27, 2 to the 1.3 equals M. 30, pi to the half equals X. 33, you rewrite as 2 to the X equals 1, and you get X equals 0. 36, you rewrite as 3 to the X equals 1/9, and you get X equals -2. 39, you get X equals a half. 40, you get X equals a 4. 93, you get X equals 3.5. 96 is a half. 99 is 3. 102 is -1/5. 105 is ln 8 minus 5/2. And 108 is -1 plus or minus the square root of 85/2. All right, couple questions prior to class because you have a quiz over those first two sections. The first section was Fogg and Goff, and the second section was inverse functions. The third section was, what was the third section? The third section was solving exponential equations. And the fourth section was rewriting logarithms in exponential to logarithmic form. Those will all be on your quiz, so come with questions over that. Before next time, here's the new stuff you'll do after your quiz. You already have this property, which is logarithmic and exponential form. Here are some other properties. This property up top says log base A of 1 will always equal 0. So no matter what your base is, if there is a 1 there, it will always equal 0. The reason for this is we would rewrite this equaling x. So we would rewrite that in exponential form as a to the x equals 0. Well, a to the 0 equals 1. A to the x, sorry, I don't know where 0 is coming from, equals 1. So anything to what power will equal 1? And the answer is 0, so that's why it's 0. Here we got log base A of A is going to equal 1. The reason for this, if we set it equal to x, we have a to the x equals a. Well, our bases are the same, so therefore our exponents equal, and that's why you get 1. So if your base and that number are the same, you're simply going to get 1. Here we have a to the log a of m. So since our bases are the same, our m, it equals m. Here we got log base a of r equals r. Some of these are hard to read. So I'm going to rewrite this one because I believe it is hard to read. We have log base a of m. So since those were the same number, your answer is just m. Here we got log base a of a is r. So since those are the same number, your answer is just your exponent. This middle section, so this first section is just properties of a quick way to simplify. This middle section is how to rewrite logarithms. So if you have two quantities being multiplied, you can rewrite it as log a of m plus log a of n. So if it's two quantities being multiplied inside of a logarithm, you can write it as two separate logarithms being added. Here we have a single logarithm that's being two quantities divided, so you can write it as two logarithms being subtracted. Here it says if you have an exponent, you can move it out in front. Here is a formula that you guys learned in IMP2, and you also did it in IMP3 in Small World. It is called the change of base formula. What you can do, because you cannot type it in your calculator unless your base is 10, so what you can do is you can do log of m divided by log of a, the subscript, and you can type that in your calculator and get an answer. This is logarithmic form to exponential and vice versa. So that goes both ways. These properties need to be memorized, so I would make sure and get them all down and then proceed to the next slide. So I'm going to go ahead and change the slide, so if you need to, pause the video. Alright, so based off of the first four properties in the first column on the last slide, we are going to, without a calculator, evaluate these. So if we look at this first one, we got log base 3 of 3 to the 71st power. So if you look at those first four properties, you need to decide which property we're going to use. You should say that we are going to use this bottom property. And so we are going to get 71 as our answer because the 3's are the same, so you just get your exponent as an answer. So look at that one. You should say you are going to use the third property since your A's are the same. So since the 2's are the same, you're going to get 7 as an answer. So use properties to find the exact value. Do not use a calculator. So we're going to do this some more. So we got log 8 of 16 minus log 8 of 2. They have the same bases, so we can write this as a single logarithm. And we are going to go 16 divided by 2 because it was subtraction there. So what is 16 divided by 2? You should say that that is 8. So based on our properties, when those two numbers are the same, your answer is 1. So here we got 5 to the log 5, 6 plus log 5 of 7. So they both are log of 5. So I'm going to rewrite that as log 5 of 6 times 7. And the reason it was 6 times 7 was because it was plus. Based off of our third property, when those numbers are the same, you just get your, you're okay. I'm videoing, yes, but you're okay.
Okay, I'm not going to have those kids come down.
Okay.
Her thing is way later than I thought, so
Okay.
I'll catch them.
Okay, thank you. So if those two bases are the same, your answer is just what is in parentheses there. So 6 times 7 is 42. And there's your answer.